Hello and welcome to the University of Pittsburgh's Health and Explainable AI, Pitt HexAI podcast series. Pitt HexAI is a research laboratory at the University of Pittsburgh School of Health and Rehabilitation Sciences, Department of Health Information Management. Headed by Ahmad Tafti, the lab cultivates extramural collaborations with other academic institutions, both nationally and internationally, through its research and educational contributions and this podcast series. Hello and welcome back to the University of Pittsburgh's Health and Explainable AI Lab. Today on our podcast series, we're going to speak with Dr. Isaac Kohane, Marion V. Nelson Professor of Biomedical Informatics, Harvard Medical School, and also inaugural Chair of Harvard Medical School's Department of Biomedical Informatics. Welcome, Dr. Kohane. It's an honor to be able to interview you. Thanks for joining us. To get us started, would you like to introduce yourself for our listeners?
Well, it's great to be on this podcast, and to cut to the chase, I am someone who thought they were going to go into biological science, went to medical school, and then realized that medical school is a fine and noble trade school, but it's not a place to develop scientists necessarily. And so I took time off to do a PhD in computer science because as an undergraduate, I had minored in computer science. And I was lucky in that when I did that, it was the second heyday. This is the third heyday of artificial intelligence in medicine. And so I did my PhD with my thesis advisor was a professor at MIT by the name of Peter Solovich. And we were looking at that time at technology of expert systems. But since then, I've explored the different applications of computing methods as we've become much more sophisticated in our analytic methods and have also progressively had more and more data to access, whether either on the genomic side, on other high throughput methods, as well as electronic health record data.
For students who are new to different informatics fields, how would you describe the field of biomedical informatics and how it compares to other medical and health informatics specializations?
So the name of my department is Biomedical Informatics because we actually purposefully wanted to not create the traditional chasm that exists between bioinformaticians and medical informaticians. Medical informaticians tend to focus on patient-level data obtained through clinical care or patient-reported. And a lot of what they worry about is things like implementation science in clinics and decision support for doctors and increasingly for patients. Increasingly now, fortunately, in the last few years, there's been a fair amount of medical informatics that has been focused on decision support with these newer tools of machine learning, specifically the tools that arose out of the revolution in convolutional neural networks, and most recently, therefore, large language models. On the bioinformatics end, it's been a very different community. It's been typically those collaborating with molecular biologists or genome sequencers, and the tools are about making sense of these genomes, categorizing them, characterizing what mutations are there, and basically trying to make some biological sense of these. Now, this distinction increasingly between these two communities is becoming more and more obviously artificial because in order to understand what is the clinical meaning of these variations in the genome, you need to get to clinical databases, which, again, medical informaticians typically have played a part in either implementing or developing. And so that's why, although bioinformaticians are focused on molecular biology and genomics, and medical informaticians are typically focused on the clinical care, it's in my mind, a false divide. And it made sense early on when these things seemed quite different. But in my own experience, the methods start getting reused across this divide. It's merely a matter of, are you willing to roll up your sleeves and get familiar with an application domain that you're not as comfortable with? So for the molecular biologists, bioinformaticians, I'd be understanding more about healthcare. For the healthcare people, it's go back to your textbooks and learn, or YouTube and learn more about the genome.
By the time a new student is finishing their studies, what new hybrid informatics fields do you think they'll see?
Well, I do think that we are right today at time zero of the eruption of large language models into healthcare, like GPT. And certainly on the clinical end, it's going to change the processes of healthcare, the business processes, as well as the conduct of medicine. But at the same time, on the molecular level, there are these other, they call them foundation models, because some people don't think of protein sequence as a language, although I do. It's essentially very much the same transformer technology being applied to amino acid sequence to actually predict extremely accurately protein structure. And it's very clear to me that future graduates will have an opportunity to select a track that is very much about the use of large language models and their offspring in conjunction with a particular domain application, whether it is diagnostics, understanding basic biology, or providing patients with individualized decision support. So this nexus of linguistically based large language models, I think, is going to transform a lot of informatics. So, for example, there's been a whole discipline of natural language processing. In many ways, that's all going to be subsumed by these large language models. Similarly, there was a whole bunch of structural biology work that was about the interpretation of radiographs of X-ray crystallography and homology between genes, evolutionarily speaking. And all that is being scooped up by these foundation models. So I think that intersection between state-of-the-art artificial intelligence and various branches of informatics will absolutely be where everybody is thinking about specializing, at least.
Yeah, so last year on a different podcast, we had the opportunity to interview Daniel Huttenlocher, the inaugural dean of MIT's Schwarzman College of Computing. And we talked some about his book, The Age of AI and Our Human Future, that he co-wrote with Eric Schmidt and Henry Kissinger. Your book and theirs both raised strong cautionary points or messages about AI looking towards the future and the need for care and forms of regulation. What should we be cautious about AI in the medical and health fields?
So in the book, I refer to a few models of validating the performance of AI artifacts. Among those models are two. The first one is what I call the trial model, which is you define a task, a very narrow task, like does this patient have retinopathy? And you can describe, and you can run a trial. You could say patients who have these characteristics can go into the trial. Those who don't get excluded. And you therefore describe a population that you're going to study. And you say, this is the performance I have to get to be successful. And let's say I have to be able to diagnose 80% of them accurately. And then you run a trial, and either it works or it doesn't work. And that's something that FDA can understand. That's something that you can publish. All well and good. And in fact, the FDA has approved over 500 device-associated artificial intelligence algorithms in that trial mode. That works well. The problem is large language models don't fit that model, because you can ask it a question. You can start asking, is this patient likely to have retinopathy? But then the conversation goes as it would with a human. What about their obesity? Do they really have obesity? Do they have diabetes as well? And it can end up being anywhere in medicine in that conversation. So then you can ask yourself, well, we already do certify competence for people with broad medical competence, and that's what I call the trainee model. So the first one was the trial model. This is the trainee model. In the trainee model, we take young, enthusiastic individuals. We have them jump through a bunch of hoops. They have to take certain classes in college. They have to take the MCAT exam. They have to go through medical school. They have to get good grades in medical school. They have to have a passing grade on the United States medical licensing test. Then they go on to residency, where they have to also behave well and get good recommendations. And you would think that maybe that's a model for large language models. After all, in the last year, large language models have gone from scoring about 10, 20% on these the United States medical licensing exams and the MCAT exam to 90% within 1 year. And so they're actually performing better than most doctors. And if you give them diagnostic dilemmas, they actually do extremely well. Problem is, when we have a human being take these exams, there's a number of other properties of these humans that we can take for granted, that they think like humans, that they are motivated by the same goals as most human beings. And we have no such assurance with these large language models. And I'm not saying that they're sentient, but what drives them is a set of probabilities garnered over the entire beast of all the text that's available on the web. And it's not clear a priori what they're going to say. In practice, a lot of what they say makes sense. In practice, a lot of it seems expert. There are occasional and sometimes frequent hallucinations, false facts, but you could say that they score as well as human beings, but because they don't share the properties of a being that's out there in the real world and that is surviving as a social animal, as part of human society, we just don't know. Therefore, I think it's inescapable that human in the loop is what's going to be required, that these large language models like GPT-4 or Google's Palm will be augmenters of physicians or physician assistants or nurse practitioners. They will not be working solo. There will be another type of human loop, which some might find scary, which is working directly with patients. That's already happening. And the reason it's already happening is because patients are desperate. They don't get enough time talking to their doctors. They'll get a diagnosis, then they'll walk away and say, I have more questions, and there's nothing to be done. Here, you have this agent that's ready to respond. And by the way, lest you think that's somehow a new thing, when internet search became popular, patients were big users of it. You've heard of people refer to Dr. Google, and even some of the sites that they would dig up were not authoritative, or in fact, proponents of harmful things. We just said it is what it is. And so I think that on the formal medical side, you'll see humans in the loop, doctors using these as augmenters, and on the patient side, them used as second opinions, as evaluators, and so on. The biggest risk, actually, for me, is not so much that they'll be misused by the doctors, but more that, just like in any autopilot, if doctors get too comfortable, they may stop paying attention. And that's when you lose the human in the loop facility. And I think what we're going to have to do is think about cognitive tools to keep on ensuring that doctors are engaged, much as well as with self-driving cars. Currently, I think in a Tesla, it looks at your eyes to see if your eyes are on the road. It checks to see if your hands are on the wheel. And if it's not, it'll say, I'm going to switch off the autopilot. And by the way, if you do this a few more times, I'm switching off your autopilot forever.
Thinking about what you were just saying, how would you view explainability in practice, and where would you suggest labs interested in explainability focus their work looking ahead?
That's a great question. Now, I think that, unfortunately, a lot of explainability research is misplaced for the following reason. I don't think I'm lazier than an average MD. I can tell you that even when I was much more involved in clinical practice, when I would get some arcane test results, let's say a mass spectrometry test result done to look at metabolites in the blood, what I wanted was not a detailed explanation. I just wanted, is this normal or not normal? And I actually didn't care too much about the explanation. And that's because fundamentally, rightly or wrongly, I trusted the call. And so it comes down to trust. For me, there's many ways you can explain what's going on, but I think more importantly, it's how does one communicate qualities that make something become trusted? And part of it has to be personal comfort with some of the decisions so that it does what you think it should be doing most of the time, so that when it doesn't do what you think it should be doing a few times, you don't say, oh, it's wrong, but yes, you say, oh, maybe it's something I should attend to. And that's the case again it's not like this is the only application of high-end computer technology. For decades, we've had CT scans and MRI machines, which actually run deconvolution algorithms that I guarantee you 99.9% of most doctors do not understand, to take the X-rays and turn it into an image. And the reason that they trust it is because these images are consistent, reproducible, and people don't worry about them. However, when a particular MRI scanner starts developing a lot of so-called UBOs, unidentified bright objects, then trust starts dropping and you start to need more explanation. So explanation really it's fun, it's important, but actually the requirement of explanation is an expression of the failure of trust. When people trust you, they don't want explanation. They just want, is this good or is this bad? What do I have to do next? If some people want explanation, that's a minority of cases. So I think that the most productive way to look at explanation is to say, how do I bring appropriate trust to bear? What can I show the user, either during this session or across multiple sessions, that will give them a progressively increasing level of trust so that they'll use this.
Okay, that's a great point. Perhaps one new and important career field for humans in the future will be to monitor, assess, and correct artificial intelligence applications, and it will be up to universities to teach students how to fill these fact-checking roles, so to speak.
I think that's a great point. And in fact, I think the checkers will be of two flavors. One will be human beings, but the other is other AI. So I'm pretty sure that if they're not already implemented, there are plans to have a GPT-4 look at the output of a GPT-4 and say, is there an error? Is this real? And you can see how having these internal conversations between these two independent agents could actually result in more robust conclusions. Actually, I've seen it happen. It's quite eerie to watch one of these GPT-4s critique the output of another GPT-4.
That's amazing. So returning to the present, you've seen so much over your career. Is there anything today that you find super exciting that you might like to share?
Well, what's exciting to me personally is that rather than this being a technology that's only available in some laboratories, it was instantly made available to over 1 million people in 5 days. And so that means that our understanding as a society of what this is doing is literally orders of magnitude different than for any other advent of technology, where only a few people get to experience it up front in a very personal way. Here we're putting patients will not be mystified by doctors talking to these large language models because they themselves will be doing it. So that's number one. The most exciting fact is that it's made broadly available. Cannot overstate how important that is. Number two, what makes this particularly exciting period is that the way to interface with these large language models is not through some arcane application programmer interface. It's through language. So, for example, OpenAI just announced a whole bunch of plugins. And these plugins don't work through some arcane API call. It's basically English descriptions of what this subroutine, this service can do for you. And that's allowing these large language models to acquire all sorts of interesting superpowers. Like now they have an API to Wolfram Alpha. And so they can say, oh, here's a polynomial. Could you get me the first derivative of it? Turns out these large language models are very good about, thinking at superb linguistic levels, even in reasoning things through, they're not very good at arithmetic. So giving them the tools that they can just call through this, again, natural language interface is expanding dramatically within just a few weeks, the capabilities of these systems. And what that means also is that these AIs are going to be pretty much projecting their influence into many of our automated systems. And that should be just both exciting and a source of concern.
As a professor, thinking about all the explosive growth around AI that we're seeing, do you have any thoughts on how we should approach education in the AI age? Instead of universities asking themselves what classes should look like in 5 years, maybe we should be asking ourselves how classes should look next semester in a month or two?
I completely agree. I just finished today teaching a course in computationally enabled medicine at the Harvard Medical School. And the time to use these large language models is today. And so let's start up from the bottom. I think at this point, instructors should be using these models to generate syllabi and then edit those syllabi to make sure that they are what they want, to generate problem sets, again, with human oversight, to generate questionnaires, quizzes, and similarly, these students should learn how to use this tool as a cognitive amplifier, whether it's for writing up a patient, for coming up with a therapeutic plan, for comparing two different drugs, for reading the literature, for getting summaries of articles to see whether you want to read the full article in a way that mere abstracts don't capture it. And in publications, I think that so long as you're transparent about who's helping you, just as we don't penalize people for using grammar checkers, if someone uses a large language model to help them write a scientific paper and they close that, God bless them, because let's not forget what we're trying to maximize here. When someone publishes a paper, of course, they think of it sometimes as an important step in their own career and getting credit for it. But its whole purpose is to communicate with other researchers, with members of the public, the meaning of the research. And if this tool can make it clearer and can make communication more rapid, then that's only a good thing. And let us remember that most of the scientific literature in the world is in English. And this has been a barrier for non-English speakers who can speak English, but perhaps don't have all the idioms down. Here you can say, write this in the style of an academic, write this in the style of Chaucer, write this in the style of a rapper, whatever. And I think that for academic communication, it's going to be immensely transformative. So I would say there's very few areas of medical education that should not be affected by these right away, and that course directors should be asking themselves very explicitly, how do I help my students enter this future where this is a ubiquitous tool, by getting them used to using it without crippling themselves intellectually.
Yeah, that's an important point. May I ask you how you would advise students to be careful about using ChatGPT? What would you recommend?
So I would, if you're about to write something, and put down a few ideas and ask GPT to write something along the lines that you're interested in with the right prompt. And by the way, just writing the right prompts means you have to get far more clear in your own mind what you want the message to be. Then read it out loud to yourself. And does it make sense? Is this the message you want? And then you can go back, either edit yourself or tell GPT to edit it. So that way you almost have like this expert editor that you're in a very tight loop with, that is exploring your ideas without being slowed down by the natural inertia most of us have in generating text on paper or screen.
Right. You mentioned publishing. I understand that you're going to be editing a new scientific journal called NEJM AI by the publishers of the New England Journal of Medicine. Congratulations. Could you tell us about this, and as an editor, how do you plan to approach uses of generative AI by authors?
Thanks for asking me about New England Journal of Medicine AI. it's, first of all, still very strange to me that I am the editor-in-chief of it, but much stranger to me is that the journal exists. It's an odd thing. When I was doing my PhD back in the 1980s, the fact that there would be a mainstream journal spinning off of New England Journal of Medicine that was specialized in AI would have seemed like pure science fiction. And what this speaks to is the rapidity of the revolution, but it also speaks to the danger. The danger is that, as we were speaking about it before, it's very hard to evaluate these AI artifacts. And doing it incorrectly might give false security or false worries about the qualities of these artifacts. And so the main purpose of this journal is to actually create an intellectual community around the evaluation of AI artifacts as applies to clinical medicine, so that we can develop a shared set of good tastes that allows us to move nimbly where, for example, regulatory authorities have yet to even make up their mind as to which way is up. That's the main goal, is the evaluation part. Now, as part of the pedagogical mission and policy mission, we're going to have various educational pieces, reviews of the application of these technologies to different parts of medicine. We're going to have perspectives from various thought leaders in this space. We're going to have policy perspectives from those involved in policy, because regulation, reimbursement, all those will play critical roles into how successful AI will be in its deployment throughout medicine. So we've gotten a very multidisciplinary editorial board that covers a lot of the planet, actually. And we're looking forward to opening the journal for submissions sometime in late May, early June. And we've already started an online podcast called New England Journal of Medicine AI Grand Rounds that is led by our two deputy editors, Arjun Manrai and Andrew Bean. They've already had some very nice podcasts with several leaders from the Google Health team, Google AI team, and from some Harvard researchers. And by the time you air this episode, I think we'll have aired a podcast with Peter Lee, the head of Microsoft Research, who's been one of the Microsoft leaders who've been helming the wide introduction of large language models throughout the Microsoft infrastructure.
You mentioned Peter Lee. Okay, so he's one of your book's co-authors. And how did you and Peter and Kerry Goldberg come about working together?
So it started because in early fall, Peter Lee reached out to me, and he and I had met each other before in various academic contexts. I had invited him to give a presentation on a monthly event I host called the Biomedical Informatics Entrepreneurs Salon, where we have entrepreneurs of various stripes come and talk. And so we've met before. And he reached out to me, and it was very mysterious. And he wanted to make clear that I could not talk to anybody about what he was about to tell me about. And what he was about to tell me about was GPT-4. And this was back in the fall of 2022. And he gave me some examples of the output of GPT-4. And this was mind-blowing. I just could not understand how a engine that just can predict the next word can actually argue logically with you or perform expert diagnoses. He also gave me early access to it, so I could try it out. And as I was thinking about it, because I was reeling, I was wondering, how can we introduce this to the public in a way that's going to create a useful public dialogue? And he had thought about writing a book. And I was a little bit presumptuous, because in his previous life, he had been a much more familiar character in the sense that he had been department chair of computer science at Carnegie Mellon. And I said, "You're so busy. How are you going to have time to write a book?" And so when he kept mentioning that, I said, "I might have someone who can help us." And so I reached out to a friend of mine that I've known for over 20 years. Carrie Goldberg was a bureau chief in Moscow when there was the crumbling Soviet Union back in the 1980s for the LA Times. She was Boston bureau chief for the New York Times, which is when I first met her. She then worked for the Boston Globe. She then worked for the WBUR NPR program that she helped create called Common Health. And then she was Bloomberg Boston bureau chief. And she was just moving on to her next job. And I approached her. I told her, you've got to not tell anybody else, but I have permission to ask you. It looks like we have something that is behaving a lot like what we said, things that might be artificially intelligent should act like. Would you like to write a story with us? And we made it clear with her from the start that she was not going to be a ghost writer. And instead, what we did is we had multiple meetings, all, of course, online, and we hashed out an outline, which we changed steadily over time. And ultimately, each one of us wrote one or more chapters. Sometimes we'd join forces, and frankly, Carrie edited all our chapters as well as writing her own. So I hope we've written it really for the general public. You don't have to understand computer science. You don't even have to understand too much about medicine to understand it. But I think you'll get a sense of both the real promise, the real excitement, and as well as where are reasonable concerns to be had around this technology.
Yeah, I think this is such an important time for books like yours. Would it be okay now if we switch topics and talk about data sharing? How important is data sharing, and how would you like to see academic institutions collaborate around sharing data?
So early on, when I finished my PhD and went back into finish up my clinical training, it became quite obvious to me that the biggest obstacle to better analytics, to better decision support, was going to be sharing of data across institutions. And that although the most commonly articulated reason to not share were concerns around patient privacy, what were motivating most of these concerns were concerns about property, intellectual property, business intelligence, patients leaking from one healthcare system to the other. And so that it was actually parochial concerns which were preventing data sharing. And a lot of these barriers inspired me to do quite a few projects that were not in artificial intelligence, but in distributed querying across healthcare systems and providing open source tools to extract data from electronic health records. You can look up tools like I2B2 and Shrine for distributed queries. And those barriers still exist. And I think that one of two things are going to happen. Either healthcare systems will understand that those who choose to share de-identified data in a controlled and safe way are going to be not only doing the right thing for their patient population, but ensuring that they're part of a healthful ecosystem. If that doesn't happen, then the other thing is going to happen. Under the 21st Century Cures Act, patients are given the right to access their own data. And some large companies like Apple are taking that right that patients have and allowing through an API, like the Smart Empire API that we and our group helped develop, to pull data from the electronic health record into a personal repository like the Apple Health data repository. And that's going to create data sharing across populations, in the United States at least, that will be at unprecedented scale. So either institutions will do the right thing, or they will be bypassed through other, I think, more consumer/patient-centric fashions. In other countries with socialized healthcare, the authorities actually have a different mechanism where they can actually compel institutions to share their data, and the United Kingdom has actually shown a productive model of that.
Dr. Kohane, before we close, we like to ask all of our guests to offer students who are interested in health and medical informatics a research project idea. What's something that you'd love to see students work on?
Yes, I'm going to pick one in the purely clinical arena and one in the more molecular arena. So in the clinical arena, I did some work in the past on growth curves. And growth curves are, if a boy or girl are growing according to these curves, that's one of the best guarantors of good health. If there are deviations from height or weight curves, then you have to ask yourself some questions. Turns out there are stereotypical patterns of growth disturbances. And by the way, this is the cheapest possible data. Height and weight can be even done in the developing world. And you can actually diagnose things like malnutrition, obviously, but celiac disease, hypothyroidism, growth disorders, precocious puberty, brain tumors, and inflammatory bowel disease. And there's so many things that can be diagnosed. So I think that a public health motivated app for patients where you just gather their heights and weights and give an authoritative, at least suggestion of what is going on would be very, very helpful. I think it's a good machine learning quest, and it's also has nice public health and equity properties. A different one would be to basically crowdsource all the annotations of genomic driver mutations that are being used by various platforms and say, if you're a patient and they sequence your genome or they do a panel, we'll provide you with an open source, nonprofit, best interpretation based on the literature that you can share with your doctor. And I think that would democratize some of the access and interpretation of these somatic genomes, these genomes that are obtained from the tumor itself, which, tumor itself has this disintegrating genome that's rapidly evolving. And I think that these genomes are used reasonably well at cancer centers within academic centers. But if you're in a rural area or in a country with few cancer centers, you're not going to be helped at all. And even with old school chemotherapy, knowing something about your cancer at that level is going to be incredibly informative for millions of patients.
That's fascinating. Lastly, what's something that students have brought to your attention that you might like to share? Is there anything new or exciting that stands out?
I would say the majority of the interesting ideas I've heard in the last 10 years have all been generated by students. And part of the privilege of being a professor is if you're lucky enough to have wonderful students, which I do, they're the ones that bring you the ideas because they have their own independent interests and they're going through the literature and doing experiments, and they come to you with interesting questions. Interesting questions is what it's all about. Having the right questions. It's not being a great methodologist, although it helps, not being a great computer programmer or computer scientist. It's having really good questions. And I find that the right students come with the best questions. And everything that I've worked on, from gene regulation to the latest work on large language models, have come to me because of questions from these students. So that's, for me, the norm. It's not the exception. I actually have trouble thinking of which ideas I've had that were not initiated by a conversation with a student.
What a nice closing for our interview. I think students will really appreciate your words. Dr. Kohane, it's been a pleasure. Thank you so much for taking time to speak with us today. Thanks everyone for tuning in and for following the show. And a special thanks to the University of Pittsburgh School of Health and Rehabilitation Sciences, Department of Health Information Management, and to Pitt's Health and Explainable AI Research Laboratory for launching this podcast. We'll see you next month.